Hello. Today we're going to take a tour through the batch processor solution. I've kind of blogged about this a little bit, and now I'm going to give you a visual tour through the code. First off, we have a BP console project. That is the application runner that runs through all of our different tasks. Has a configuration reader in there, has our config files in there. BP processor is the actual code that does the handling of the multitasking, and then busy is a console application, kind of the reverse of the sleep command. Busy does some operations just to keep the CPU busy and occupied for a given number of seconds. So let's start off by looking at busy. It takes a single command line argument, which is the number of seconds. I would do some error handling there. Then here's where we really get to work. Here is our class busy. Number of seconds we want to stay busy, just defaulted it to 5. So elapsed time, that's how much time has elapsed. Then we have the method spin, has a timer in there, and our elapse is tied to the timer elapse. It updates it once a second. We start it, we have just a work value, and then while we're in there, while elapsed time is less than duration, we're just going to go and run through and just do some stuff to make the computer work some. And then on our elapsed event, all we're doing is we're incrementing elapsed time. So the loop runs through for the given number of seconds. So that is the busy class. And we'll take a quick look at that, our console. So you notice over here I've got a CPU usage going on over there. So I'm going to run here busy for 10 seconds, and we'll notice that we're going to see a spike in one of the cores. There we go. So some of the core 7 there kind of spiking out a little bit. Alright, so that's done. Now I come back over here, and we have our program, and what our program does is it's set up for when we want to run only one task at a time, do serial processing. We're going to use the same code, same classes that we use for the parallel processing, which we've got set up for doing 4 at a time, but we just set it to be 1. Our main's pretty straightforward. We want to run the setup tasks, then we're going to run through the parallel tasks, and then we're going to run the teardown tasks. So the setup tasks, or we do serial processing on the setup tasks, and we do parallel processing in the middle on a parallel task, and then we have any serial tasks that need to be done at the end. So you have to do some data preparation or setup at the beginning that needs to be done in a certain order. Then that's when you do your serial processing on that first run. Then you have a number of things that can be done. Say you're doing different computations that don't have any dependencies on each other. You can do those in the parallel task run. If you have a job that, say, maybe needs to have something done after it finishes, you can set that up as a batch job, or one job that calls the other job. So once process A finishes, you can set it up to call process B in that specific application. So that would be how you would resolve that in the parallel task run. And then at the end, you have teardown tasks. So maybe at the very end, you're going to do something like you want to maybe FTP the results off to a server. So for instance, that's where you would do that in the teardown tasks. And you see we're using this config reader, get task list, and so what we're doing is we're going out to the different configuration files. We have setup tasks, parallel tasks, and teardown tasks. So we're going out to those different configurations. We're reading in the contents of those configurations, and that's returning us our task list, and we're feeding that into the processor object there. So if we look at our setup tasks, we're just running a busy here once for 3 seconds, just simulate doing some setup. Also notice that you can use the C++, Java, C# comment convention here at the beginning of the line or even at the end of a line. So same thing here in the teardown task. We're just running a little busy for a little bit. Then we have our parallel tasks. It is beneficial to try and put the larger items up front, and then the little ones can fill in along the way. So even though you're running things in parallel, it does help if you can, and the scheduling is dynamic, it still does help to put some thought into when they might come up in the queue. So you may want to look at those jobs that are being run, put the bigger ones up front and then the smaller ones towards the end so that they can fill in. Because I mean, what could happen is you could get to the very end and say you had a whole bunch of little ones, and then you had one at the very end that was a busy 20, and so that one's the last job running, and it's going to take a lot of time, so you maybe end up waiting for that one job, where if you'd put it up front, it may have been running quite a long while on a single processor, and then the other 3 processors would be handling these other jobs. This is the configuration reader. It just takes a file name, and we've got designated what the comment designator is. So if you wanted, you could change that out to be your, the dash or some other mechanism. Wanted to stick with the familiar there. So this is kind of fairly basic stuff. We're going through and just reading that file in and putting it into a list of string. Here's where some of the interesting stuff is, where the work is done. So we have our job list that we're getting set with this number of processes. So, and then so that's like a default there on our default constructor. However, because a lot of machines anymore are dual core. So if the way we're running it, though, we're using 4 on a quad-core machine. This happens to be a i7 machine, so quad-core hyper-threading, so it looks like we have 8 cores over here. We just have some straightforward add jobs, note if the execution is completed, and then we have the execute. So we're using the system diagnostics process, and we're setting up a process to run for each one of these jobs, and we're looping through based on our number of processes that we can run here too. Okay, so we notice this use shell execute, so if it's false, only EXEs can run. So this allows you to run, like, for instance, batch jobs. We're not changing the working directory on these. What this does here is the file name. You have to do a little bit of work. So in order for us to do things like the busy3, the command and then arguments, we had to split it, get the file name, and then we have to set the arguments up, or the parameters to that command have to be kind of put together again after that. We set it up so it comes up in a regular, like, command window, and then we're checking for an open process. So there we go. These checks must be in this order, because if the process has not been initialized, the .has exited will throw an invalid operation exception. So that's why this is set up like that. So what we do is we go through and we have that. In this instance, we're going to have the 4 processes, and if it has exited, then we're going to set it up to do the next process. And so that way we can have, say if you have jobs running on cores or processes 1, 2, 3, and 4, and process number 3 finishes before 1, 2, or 4, then we can assign our next job to process number 3. And if there's an error along the way, we write it out to the console. So and then of course at the very end we wait and make sure everything has finished up. And then once we're done, we set execution completed equals true. Right along, we're out of there. So now let's take a look at execution of the code. So we'll come over here, and you're going to notice we're going to have a single window come up for just a couple seconds. That's like our setup. We'll see quite a few windows flashing up as we're doing our processing, and then at the end we'll drop down to having a single window. Do our teardown, watch the CPU usage over here as we're running, so you can see that these are actually tying up CPU. So there's our setup. There's our multiple tasks running, so there's our setup finished. Doing our multiple task computing right here. There, as those jobs are finishing, we're jumping into our new jobs. The windows are clearing up, going away. Our CPU is pegging out over here. Jobs changing. And our teardown task. And that's it. So hopefully this may be something that you may find useful in your work or your studies.